So, looks like putting savings and cash puts you on business track automatically, right? The thing is, this talk is a little bit technical, so sorry if you came here to learn about cash and savings. It's kind of related a little bit to the business part of the thing, so I think it's going to be interesting for you to learn as well. So this talk is going to be very interesting from standpoint. I'm going to do a small demo at the end, and in order to do the demo, I need to start running a demo.sh. So I'm going to run a load test, and all the things that I'm going to discuss in this presentation, we're going to see before and after in real time during my talk. So let me start the demo itself, and let me start my presentation. So first of all, I just realized today that I'm already 18 years. Test. Okay. So I just realized today that I'm already 18 years with Magento. So I'm one of what they call grandfathers of Magento. So I'm very passionate about open source. I also was and still an expert in performance optimizations, and I'm one of the grandparents of Magento. So I was in team of first 5 core developers back in 2007 in Kyiv. We were having an office at the residential building in Kyiv, Ukraine. And this office was like the first office of Magento development ever. We had very nice moments. We had a lot of fun situations over the time. And I was on a team of 5 big guys. So Dima Soroka, Mikhail Besolo, Andrei Korolov, Boris Gurvits, and me. So I'm very experienced in putting out fires in production system. So for me, like optimizing performance, it's like one of the most common things that a lot of merchants face when they run a system in production, right? And it's very important for me to make sure that I have to do less business, right? So for me, it's better that you as developers, you as companies, deliver something that runs on cheaper hardware so I can solve complex problems. So I don't have to solve all the time the same thing all over again, right? First, let's start a little bit with different cache types. I think a lot of people think about cache types like, okay, there's block HTML cache, there's like varnish cache, there's data cache, and so on. But I split them in 2 categories. So one I call runtime cache, another one I call build time cache. And the runtime cache I call expensive cache because it costs you money, like to store data in Redis. It costs you money to generate this during the requests. And there is another type of cache called build time cache, and it's very cheap. So in my honest opinion, everything that is on the left, as much as possible, needs to move to the right. Because I want to make sure that when we build our build artifact, right, we have already all the cache we need. Because honestly, layout structure, it's already based on XML files on a file system. You already know when you deploy project which final layout structure is going to be. Configuration cache as well, right? Configuration cache, it's only like a couple of values are changing based on environment or based on database table queries. So this is one thing that needs to be moved to the build time. And I'm big opponent of collection data cache and block HTML cache. And today we will learn why and how actually we can do something with it without compromising performance. So we can get rid of this cache, and I'm going to show you a demo at the end of the presentation with it. So one of the most common things when we talk about cache is having a low cache hit ratio, right? If like we had 100% low cache hit ratio, like everyone would like cache, right? Everyone knows like, oh, we're going to have everything being retrieved from some fast storage. However, the low cache ratio and too much cache variations do not combine together. So imagine you have somewhere in Redis stored data for each product or for each product variation of a configurable or so on. That's too many cache entries. there is very small possibilities that you will ever have 100% cache hit ratio, because something will come from ERP system, something will come from PIM system, people will buy products on a website, cache is never going to be warm. So here I would say like it's already a sign that you shouldn't cache this data in Redis. Another thing is, right, high frequency of updates as well, just what I was talking about. And another one is aggressive cache eviction. So imagine like you have only like 3 gigabytes on your server and your cache gonna be very quickly filled up because you have too many cache entries. In that case, you will have aggressive cache eviction gonna happen because Redis will just remove old cache entries from cache, and then the next time someone visits, oh, we don't have cache entry anymore. We are hitting again Magento backend. So possible solutions to that. One of them is reduce cache variations. So what I see a lot, especially in extensions, people just build cache keys with a lot of input arguments in it. Let's say we have cache for this small block where we have an attribute, a value, affecting the final cache value. However, this big structure is the same for majority of the products, right? So you have like 99% the same data. The only difference is this small attribute variation. So what you should do in this case, you shouldn't have like one big piece of cache. You should slice it into smaller parts. So one is that doesn't change based on a lot of variations, and another one that is going to be changing a lot. And that another part, maybe you don't even need to cache. Another thing is removing the cache and optimizing the underlying slow generation. So I was asked today a couple of times during the conference, like, what are 3 things a developer should do to start optimizing performance or take a look at? And I would say there is only one thing that you should do. You should use profilers, right? If you don't know how your code runs, you will never optimize your performance, right? So there is no top 3 things. There is one thing: use code profilers. Another thing is, of course, like you should batch cache flushes together, because sometimes you have async events that are happening and coming over from external system, and then you all the time flushing the cache because you do it one by one, and then you never have a stable website because you all the time hitting some cold cache storage. So it's better to take a look. In Magento, you can specify for consumers, you can specify merge strategy, and you can write the small customizations to batch together all of those consumer messages that update everything at the same time. Another thing is atomic cache writes. So what does it mean to have atomic cache write? It means you keep old cache entry alive while you are generating a new one. So you never have no cache entry at all. And in that case, if you update something, you already generate a new version of the cache at the same time. So this can help to solve a problem of low cache hit ratio. However, I'm not a big proponent of cache. And one of the biggest problems in Magento that I see all the time, it's layout cache. Anyone uses here Magento widgets functionality for categories and product pages? Anyone knows about such functionality? But no one using it, right? So one of the most important things is this functionality kills your Redis clusters. Each unique entity in Magento has own version of XML layout stored in Redis storage. So imagine like you have 1 million products, so you have 1 million Redis entries for each of the products, right? That doesn't make any sense. Another thing is most of the layout is actually the same across all of the entities. Maybe there's like small customizations applied if there is widgets are used. Another thing, on large catalogs, the cache can actually grow to 20 gigabytes in size. However, then what you are doing with your life if you have these big cache storages, it doesn't make sense to have something. The source of the problem comes from this pesky method called add page layout handles that exists in layout builder itself. So you have this parameter called entity specific, and this one will multiply all of the parameters, like entity ID for product is going to be ID and SKU. So you have like 2 variations being added to the final cache key. And the quick fix for that is actually create a plugin for this specific class. If entity specific is set, what you can do as a quick fix, right? So it's not the fix if your customer uses this widget's functionality, but if your customer don't use, you can just disable it by checking if entity specific equals to true. Then you just don't execute anything from original method. Very simple one-line fix that saves a lot of storage on your Redis servers. Right, so we see entity specific equals to true, and then if it's equals to true, we just return true. We don't proceed with original functionality. Another thing, Magento, if you have like a lot of fashion merchants who have a lot of configurable products with a lot of variations, Magento has another cache that is actually hidden. Like you don't even have it on a list of cache types. It just exists without any cache tag associated with it. So it's only flushed when you flush all on Redis. Each time you use get used products in Magento on the front end, Magento will store the whole result of this collection in products. The whole list of all simple products is going to be in that cache entry. And it means you will have at least like 1 megabyte, 2 megabytes per product stored in Redis. It doesn't make sense. Also, the problem is that as soon as you update stock quantity on any of those products, that cache entry is going to be invalidated. There's going to be no cache anymore. So the quick fix, it's actually one line. You just disable this use product cache plugin. You create DI file, and you just say plugin disabled equals true. Here is the code, right? So you just need to implement this one line. So with both of those fixes applied, on majority of Magento stores, your Redis will never go above 20 megabytes in size, unless you have additional cache, of course. But on core Magento install, that's a kind of small amount, right? So you can live with that. Another thing is low varnish cache hit ratio. Everyone uses varnish, I hope, right? It's the best solution for full page caching. Redis is quite bad for that. It's busy with caching configurable products for Magento. So Magento has this nice cookie called xMagentoVary. And inside of that cookie, Magento puts a lot of data that generates another variations of the cached page. So let's say you have a home page and your customer is logged in. You have one version of the cache. If customer is logged out, you have another version of the cache. If customer has a different customer group than the default one, it has another version of the cache. So you can have like 5, 6 variations of the same page in Varnish being stored. It is actually quite hard to fix as a general solution because every merchant is different. But a lot of merchants I work with usually don't have prices per customer groups. So for B2B stores, yeah, you have prices per customer groups, then you have to have a cache variations. But let's say if you have the same data for products for all of the customer groups, you probably should drop that value completely from the generation. So what you can do, you can grab this HTTP context class, and you can update get data method from it, and then you will have the same cache for all of the customer groups, right? So you can remove dependency also on HTTP context, and you can create unique values based on your own cookies, because HTTP context relies on Magento PHP code, and let's say if in JavaScript you decide, hey, I want to have a different currency being shown, I cannot generate this HTTP context cookie in JavaScript. I have to do a call to backend to do something. So it's a little bit inefficient. So it's better to create own cookies for those specific cache variations and use them in your Varnish configuration file. Another thing is very good for improving Varnish cache hit ratio. Anyone of you using Xkey in Varnish? Anyone heard about it? Oh, okay. So Varnish Community and Varnish Enterprise, both of them have some variation of cache tags-based invalidation, because by default, when you purge a cache in Magento admin, it sends a ban request, and ban request right away destroys your cache entry in Varnish. So it's not anymore kept in memory. if you are using X key or Y key, if you are on Varnish Enterprise, then your cache will live until the new version of cache gets generated. So you still can maintain good scalability of your Magento store by serving stale version of the cache for maybe a couple of seconds while the new version is getting generated, but you don't lose your old cache data. This is kind of like removes any possibility of cache pre-warming, because then your cache just lives forever. Another thing, probably none of you tried to fix that. This is actually a very interesting thing. When you have Varnish enabled, Magento has this nice block called menu, right? Top menu with all the categories. And those categories are then, if you have Varnish enabled, will be included as ESI include as a separately cacheable HTTP request. So you can see it in Varnish log. If you inspect on production, you can see like it's a separate cached entry. But the problem is Magento kind of replaces the output of that block with ESI include, but Magento still renders it every single time for every single page out there. And that rendering process adds, on some merchants, around 300 milliseconds to the render time of the page. So the quick fix, prevent render non-cached element if block is having TTL attribute on it and you are in Varnish context. Here is a very simple plugin for that. You have around render non-cached element. You check, you grab the page config object to know if it's enabled. Then you check that it's Varnish, because only Varnish does those ESI includes. Then you check if layout is cacheable. You don't want to prevent rendering on non-cacheable pages. And another thing, then you get a block. You check that the block is instance of this abstract block, because only abstract block has this TTL attribute that can be replaced. And then when you get this TTL attribute and it doesn't equal to null, you just return an empty string to tell Magento, hey, I've just rendered something, right? And it's then gonna replace your empty string with this ESI include tag, and then you prevented rendering completely on a page. Okay, let's walk through again. So we have to check that it's enabled. We have type to check it's Varnish. Then you check that page is actually cacheable. Then you check that there is an abstract block, and you check that it has TTL value. And then you just return an empty string. Another problem that Magento has, have anyone of you noticed that sometimes your category pages, product pages, are rendering very slow? However, you optimize it to the maximum, you know, like there is nothing bad happening. Anyone? Okay. So there is this nice module in Magento called persistent shopping cart. What it does, on every single HTTP request, it doesn't matter, are you in shopping cart, are you in checkout, it just invokes this, this plugin invokes get quote method that loads the whole quote, calculates totals, everything. It might even do API calls to some payment system, shipping providers, just to check if cart is expired, right? This is kind of bad. We know like some people use this functionality. I honestly didn't see yet any merchant who use persistent shopping cart. But Magento still, for every Magento store there, just checks if it's expired or not, even if you never used it. So this full load operation actually triggers a lot of unrelated stuff on page rendering. And it's a very big problem, especially in B2B merchants, because B2B customers are usually having huge shopping carts. And the bigger shopping cart is, the slower it is to render. So the quick fix for this problem, create a plugin around this helper data in Magento persistent module. And it has this method called canProcess. By default, it always returns true in Magento core. But you can create an after plugin on it. And you can check if your URL contains customer or checkout as a part of the request path. And then you return true. Otherwise, you don't want to invoke this observer at all. And then you don't load all this shopping cart garbage that exists there. So you do it only on customer endpoints and checkout endpoints. That's, I think, more reasonable, right, to do. So here is an example code of that plugin, right? We take the request because that's the only way for us to get the request. Then we check if it's a GET request. It starts with request URI, and it starts with customer. And then we just return false. Now it's time for the demo. I hope the load test has finished. So let's take a look. Yeah, so everything is done. So I run a live load test. I see there is some sort of InfluxDB errors. Okay, this doesn't matter much. The most important thing is here, the Redis dashboard. So here I have two cache runs. The first cache run was using standard Magento implementation, and you can see the memory was growing and growing and growing. And then it is very stable, around 11 megabytes. And here you can see number of cache keys as well, growing, growing, and growing. And then we see it's stable again. So let's take a look at the results itself as well of the loaded testing tool. So this is probably something happened with my InfluxDB to store this data. So let me pick up some of the information from the last 6 hours when I was running it as well for the test. Let's see, last 15 minutes or 30. Okay, yeah, something happened with my storage. But here you can see the original Magento implementation, right? You can see that, or it's not that one. Just a moment. We have no data here. Okay. I wanted to show you also the numbers of the output, but let's take a look at this one because it was unable to write to my InfluxDB storage to show you a nice graph. But we can check it here because here we can see that I accessed 7,500 different pages in my Magento store. I had like 15 concurrent users who were browsing. Then you can see that request time waiting, average time of waiting time is 333 milliseconds. The minimum is 213. And the maximum time is 1 second. However, the P90 and P95 are all below 500 milliseconds. If we can take a look at earlier result from Magento core implementation, here is how Magento responds. The average response time is not 300 milliseconds, but 500. The minimum time is 339. The medium is above 500 milliseconds. The maximum is 1.5 seconds. And P90 is more than 600 milliseconds in the response time. So what I wanted to show you and change a little bit your point of view on is this specific part, right? So this part is when Magento using a lot of Redis cache. So what's important to understand that Redis cache doesn't save you time. Because what you see here, there is like 156, as far as I remember, total cache keys. So, or 54. Oh, 64. 164 total cache keys. And under those numbers, with this size of the Redis storage, Magento was performing better in response time. The most important thing, use profiler. Make sure that your website responds fast. And that's, I think, should be the main takeaway, together with a lot of nice tips for you. So you can access the presentation slides by this URL. And thank you very much for your attention. So hope you all like it. Yes?
Profile under when you're doing load test, or do you profile the pages separately? Not
depends. So in production, I usually like to run some tools like Tidaways in order to have a real-time APM monitoring together with information about all the I/O calls. And when I try to fix specific problem, I do profile for that specific page load time to see what's going on with cold caches, right? So I want to make sure that I optimize the cold cache start, and then I can have a better response time. Okay, if you will have any other questions, we can meet at coffee time just in 5 minutes. Yeah?
Yeah,
because in basically as per speed performance, one is code part, another is rendering, like if we are using Luma theme, mostly we are having problem with the JS rendering, like we have GA and GTM integrations mostly they take some time to load. So
Yeah, so it's very interesting because most of the things that I see on Luma and Hua-based projects, even as well, is if you run a New Relic query to see how much time spent on time to first byte and how much time is actually LCP and FCP parameters for performance, you would notice that time to first byte takes 60% in majority of Magento instances. Unless you have very aggressive varnish cache, then you actually have a problem with the front end. But before you fix backend performance, whatever you do to optimize front end is not going to help you, because you will have still huge piece of the code that is going to be generating your pages slowly. And from point of view of Google Tag Manager, what you mentioned, yeah, I think Partytown is a good solution for that, right? It's running all those GTM events in Service Worker. So it's a good alternative. And actually in JavaScript, you also can use profilers. You can open Performance tab of Google Chrome and you can start profiling your page load.
thank you.